Welcome to day 7 of the hardest questions challenge. This is a higher question from 2018, paper 1, non-calculator obviously. Have a look at the diagram. You've got a circle with a tangent BC. That means it touches it at one point only, at B. There is also a straight line AOC which passes through the center of the circle at O. And we have to find, it's given ABO, angle ABO is denoted as X, and we have to find angle ACB in terms of X. So first thing we're going to do is to mark on the angle X. So ABO, is this angle here. This is X, okay? So we have to find this angle here in terms of X, and we have to further give reasons. These are written reasons for each stage of your working. That means any calculation you do that involves an angle or calculating an angle should be supported with a written reason. Otherwise you won't get marks for missing those reasons. Now, let's have a look at this. If you're in higher, you should have covered circle theorems. And there's a couple of things we can figure out, and I'm going to write the reasons for them as well. First of all, quite obviously, well, it should be obvious that triangle AOB is isosceles because this is a radius. This is also a radius. And as we know with isosceles triangles, the base angles are equal. So this angle here is also X. So angle OAB equals X. So I've made that calculation, I've made that assumption, and the reason I've done that has to be written down because base angles in an isosceles triangle are equal. Okay, keywords, base angles, isosceles, equal. Okay, next thing, I'm now looking at the bigger triangle ACB. I have to work out this angle here. Let's call this theta. Okay, so if I'm trying to find out theta, I know that the angle at effectively CAB over here, right, we've just found is X. Okay, so this angle here we've got. We now need to figure out what this angle is, CBA. We know part of it is X. And if you remember, one of your circle theorems is going to give us the other part of that angle. In other words, this angle here is going to be a right angle because you have a radius OB meeting a tangent BC. And when a radius meets a tangent, they are perpendicular to one another. In other words, that's 90 degrees between the two. So therefore we can say that angle OBC equals 90 degrees. And the reason is because a radius meets a tangent at 90 degrees, or you could use the word perpendicular. Okay, so radius, tangent, 90 degrees. They're the key parts of that written response, that reasoning. Now we have triangle ABC. angles in a triangle sum to 180 degrees. You'd use the word add, same thing, add, sum, exactly the same meaning. Okay. The reason I've written that reason is that I now know that I've got a missing angle here. So in other words, the angles in a triangle, let me just move up a little bit. Angles in a triangle sum to 180 degrees. Therefore, if I take 180 degrees and I subtract from that this angle x and this angle x plus 90. Okay. Let me do that again. I've got angle x, I've got angle x plus 90, and I add those two together and subtract from 180. That will then give me my missing angle theta. So let's tidy up the x plus 90. That's obviously 2x plus 90. So it's 180 minus 2x plus 90, which would be 180 minus 2x minus 90. Yeah. So in other words, I'm really just expanding that bracket with negative 1 lots of 2x and negative 1 lots of 90. Negative 1 times 90 is negative 90. Okay. So this is 180 minus 90. I'm just collecting the number terms there. 90 minus 2x. Okay. There is your answer for the size of angle ACB in terms of x. Hope that helps, and if it does, see you back here for another one.